Will all novae become type 1a supernovae? Does the sun eat comets? And is our search for life outside Earth intensifying over time? All this and more in this week's question show. Welcome to the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. Now, just a reminder, this is the penultimate question show that you're going to watch. So we've got one more question show next week and then we're off for our summer hiatus. So quick, ask your questions. All right, let's get into them. Chemical burn. Why is the star undergoing a recurrent nova instead of accumulating enough matter to undergo a type 1a supernova? Will this nova cycle break eventually and lead to a supernova? So, what is the difference between a nova and a type 1a supernova? So, with a nova, you get a white dwarf star that is accumulating material from some binary pair, some partner star. It accumulates enough material on its surface, it creates this shell on the outside of the white dwarf. But this shell is made of hydrogen, helium, the kinds of stuff that the white dwarf remembers burning in the past. Because now the white dwarf is just like carbon, neon, oxygen, other heavier elements, and it doesn't have any hydrogen or helium left. And so now it's got this fresh fuel that it's stolen from another star. It builds up to a certain amount as a shell on the outside of the star, and then it ignites in this thermonuclear flash. It burns it all off, and then it starts again. All right, so that's a nova. A type 1a supernova, and this is just like one kind of supernova, you have a white dwarf that is consuming material from a partner star, and it gets to a certain point, 1.4 times the mass of the sun, also known as the Chandrasekhar limit. And then at that point, the white dwarf ignites this outer shell of hydrogen and helium in this explosion and completely blows itself apart. And so you might ask yourself, isn't that the same thing? Like, isn't it just a degree? So you've got a nova, you've got this white dwarf star and it's feeding on material from a partner star, and then it collects a bunch on its surface, has a thermonuclear explosion, maybe it's left with some kind of residue on the outside of the star, and then it starts again, it gets more residue, and eventually it creeps up to that 1.4 times the mass of the sun, and then the full thing just detonates. And so do novae turn into supernovae eventually? And the answer seems to be no. That in fact, there doesn't seem to be this sort of chain, this growth where you start with a white dwarf star that has a regular recurrent novae and then eventually it goes supernova. There's something different about a type 1a supernova. Something happened to the white dwarf that was different than what is happening to the white dwarf that is causing a nova on a regular basis. So I'll give you some examples. Like, one possibility is that the white dwarf is really, really close to its star. So maybe in the beginning, the star is extracting material from its partner star, and it's not very much. But maybe if the two stars are spiraling inward towards each other, you get to this point where the white dwarf is able to consume a lot of material from the partner star at the same time. Another possibility is that the white dwarf gets fully engulfed by its partner star. And it appears that some type 1a supernova have been seen where they have gone off inside another star. So like, obviously it was easy for them to accumulate that much additional material. So right now it's thought that about 10% of the stars that go nova on a regular basis can eventually go become a supernova, but there's some different process. It might be that there's a much more powerful magnetic field that's channeling material, force feeding the white dwarf so that it grows really quickly and detonates as a supernova. So right now, astronomers don't entirely know, but it really doesn't feel like there's a link, even though the underlying process seems almost identical. I'm sure you noticed the Star Trek planet name that appeared above my shoulder, and this is a way for you to vote, for you to tell us what you thought was the best question of the week, the weirdest question of the week, the most intriguing question of the week, by whatever method you want to decide. And so the winner this week was Thomas Kluza 3663. What is the farthest object going around the sun with a name? So thank you everybody who voted. Now we're going to put a different Star Trek planet name up above my shoulder for each question, and we'll put a list of them in the show notes. And so at the end of the episode, after you've watched the entire show and you can think very carefully about what you thought was the best question, then go ahead and just put that name, that planet name, down into the comments, and then add your own question on top of that. And then we'll count them up and we'll celebrate next week. Mike Sully 7212. How often do objects fall directly into our sun from the outer solar system? So we don't exactly know how often objects are falling directly into the sun, but we know that it happens. And this is thanks to NASA's SOHO spacecraft. And this is a spacecraft that is directly pointing at the sun, and it has a coronagraph that's able to block the disk of the sun. And so instead, it's looking at the atmosphere of the sun, from the inner to the outer atmosphere. And SOHO is the most prolific comet hunter that has ever been built, even though this was not its plan. It was never intended to detect comets, and yet it recently found its 5,000th comet. And these are classed as sun grazer comets. These are comets that are coming, in some cases, from the Kuiper belt, but mostly these are coming from the Oort cloud. These are these long period comets, and they experience some kind of gravitational perturbation. They fall for up to 30 million years, and then they fall right into the sun and they're destroyed. And so they either make a really close call past the sun and they get broken apart, vaporized, but some definitely are going directly into the sun. So I don't know how many there are, but like I said, in its more than 20 years of operation, SOHO has seen 5,000 comets. So it's going to be more than that. Hovato Lezi. Can the US Army not gift one more spy satellite? We can call it Hubble 2. Don't they have like a dozen of them in orbit? Wouldn't that be cheaper than trying to repair Hubble? Plus there's no technology capable of docking and servicing Hubble right now. Well, actually, the National Reconnaissance Office donated 2 Hubble-class telescopes to NASA back in 2012. Now, these aren't exactly Hubble. They're actually a little better. They've got the same size optics, 2.4 meters, same size as Hubble, but they've got a sort of better glass, better optic system, but they're also shorter and have a shorter focal length. And so they're better for a sort of wide angle view of the sky. And to think that the National Reconnaissance Orbiter had 2 Hubble-class telescopes they just didn't need anymore, and they were like, well, we're just going to throw these in the trash. So do you want them, NASA? And NASA said, yes, please. Now, the first one has been called the Nancy Grace Roman Telescope, the Roman Telescope, and it is going to be launching in 2027. And it's going to use that wide field of view. It has an infrared instrument that's been attached to this wide field of view, and it's going to be helping us map the large scale structure of the universe. It's going to be finding exoplanets. It's the one that's going to have a coronagraph to be able to view Jupiter-sized objects around sun-like stars. It's going to be finding objects with gravitational lensing. It's going to be an amazing telescope. And so that's one of them. And sort of like a nickname for these, they call them stubby Hubbles. So now the other one, there's no plans for it. Now NASA, back when they got the 2 of them, the one they immediately knew that they wanted to build this thing. Originally, they were going to call it W first. They had an original plan to build this telescope. And then when they got their hands on this excess Army surplus telescope, they modified it. They modified the W first to actually make a much better telescope than what they were originally planning. With the second one, they haven't been able to figure out what the plans are. They don't have a lot of funding for it as well, but they reached out to the astronomy community, asked people to vote, tell them what they thought, and they got a bunch of ideas. Now, the rules from the National Reconnaissance Office, I guess now Space Force, is that you can't use it for Earth observation. And that's too bad, because that's what the telescope was designed for, right? It was designed for Earth observation. There are telescopes better than the Hubble Space Telescope that are pointed at the Earth, observing it. In fact, they're not good enough anymore because they have better telescopes, and so they threw them in the dumpster. Just let that sink in. And so there's a couple of plans. One is to maybe view parts of the Earth's atmosphere, to be able to view the ionosphere. And the idea that I like the best is to take it to Mars. That you take this telescope to Mars and then use it to map the surface of Mars. And it would be about 4 times as good as the Mars Reconnaissance Orbiter. So who knows? Maybe in the future, the second telescope will be used to fly to Mars and image the surface of Mars and like do its original job of spying, but it'll be spying on Martians. Pet pleased. What discoveries on Titan and Mars could drive scientists and policymakers to prioritize their colonization, and what implications would this have for human space exploration? I can't imagine any discovery that could be made on Mars or Titan that would drive the colonization of those planets. I guess one is a planet, one is a moon. I can imagine scientific discoveries that would drive additional research stations. You can imagine them realizing that there is active life on the surface of Mars, that there's active life on the surface of Titan, and that would definitely drive some kind of additional research budget to try and get to the bottom of this. I mean, it would be, man, if you could find some life form on Mars, bacteria or larger, that would be impressive. And then the big question that you've got to ask yourself is, do we share a common ancestor with that life? Is there some kind of panspermia that is allowing life to go from world to world within the solar system? And so if we do share a common ancestor, when? How far back? Because you can just check the DNA of the Mars life and check the DNA of Earth life, and you can figure out when they were on the same part of the tree. And we would know when life went from either Earth to Mars or Mars to Earth. Did life start on Mars and then arise on Earth? Like, that would be a mind-bendingly important discovery to make and would require a lot of scientific research. So if Perseverance, or say with the Mars Sample Return mission, they find evidence of current life on Mars, or even past life on Mars, I think that would be interesting enough to devote a lot of money to be spent. And even if the life was not related to us, what if the life did have DNA, but doesn't share a common ancestor with anything on Earth? And that means that the kind of life that we have here on Earth, DNA, is the kind of life that we should expect to see anywhere across the universe. And what if we find that the life doesn't use DNA, that it uses some other completely different method of replicating its form? That would also be incredibly important and interesting. Probably the most interesting outcome would be life as we don't know it, because it would give us ideas on how life could be out there across the universe. So really, life is the key. But I can't, even if life was found on Mars, on Titan, it wouldn't lead to the colonization. It would just lead to a research station that would just grow in response to the complexity of the work that needed to be done on Mars. Sandy Trunks, I only heard that SpaceX has canceled the moon mission. What are the chances that NASA will finally commit to robotic missions instead? You're probably mixing up a bunch of stories. So the moon mission that was canceled was this Dear Moon mission from a Japanese billionaire who was going to be doing a flight around the moon, and he was going to take 10 of his friends, 10 creators, to come on this journey with him. And Tim Dodd, everyday astronaut, and a bunch of other poets and musicians and stuff were going to fly on this mission. And we got the news a couple of weeks ago that he's canceled the mission. Now, it's been about 6 years since he originally put down his deposit to do the flight. And we only got the announcement of the people who are going to do this about 18 months ago, and then it's been canceled. And we don't know why it's been canceled. Maybe it just took longer than he was expecting. Maybe his financial situation has changed. But this has nothing to do with NASA. This is just a customer of SpaceX. Now, the second part of your question, what are the chances that NASA will finally commit to robotic missions instead? NASA is incredibly committed to robotic missions to the moon right now. We saw the Odysseus lander attempt, which was a commercial mission that was going to be flying to the moon. And this mission was going to be carrying a bunch of commercial payloads, but also a bunch of payloads for NASA. And in fact, there are a bunch more private commercial missions which are going to the moon. They're going to be carrying a bunch of NASA instruments as well. So, with the various orbiters that are going, with the various landers that are going, there's a lot of robotic exploration of the moon. And that's going to be followed up by the human exploration of the moon as well. So, right now we're in 2024. We still don't know if Starship is going to work as intended. We don't know how long it's going to take for them to be able to get to the point that we know that Starship is going to be a safe vehicle for carrying astronauts down to the surface of the moon. But right now, NASA has chosen that they're committed on that pathway, and they are already testing out the spacesuits they're going to use to take Starship down to the surface of the moon and walk around. They're testing the elevators. They're testing the the docking port. So, it could be that things are going to be delayed, but you're going to see a combination of robotic and human exploration of the moon from here on out. Visto Tutti, regarding optical telescopes on the moon, would lunar dust not be an issue? Starship put dust into orbit when landing. So we still don't entirely know what the impact of lunar dust is going to be on the moon from rockets landing. So we know that when the Apollo missions took off from the surface of the moon, it kicked up a lot of lunar dust. And people have calculated that if large spacecraft were attempting to land on the surface of the moon, it would kick up dust into lunar orbit that would then be going incredibly fast, impacting spacecraft that are orbiting around the moon. And then, of course, all of this dust is eventually going to settle back down on the surface of the moon. And because there was no atmosphere to put this stuff into a free fall terminal velocity, it's going to be going as fast down as it went up. And that could be many kilometers per second. That's going to be impacting objects on the surface of the moon. People, buildings, rockets, telescopes, and so on. And so this is a more general question that we just don't know the answer. But right now, a lot of people have done a lot of simulations. And the answer seems to be we need to be careful that, when you have a spacecraft that goes into orbit around the moon and you've got another spacecraft that just landed on the moon and has kicked up a bunch of the debris, now your spacecraft is going to be flying through that debris. And it could just be like a light polishing, or it might be very destructive. And so to all of this stuff right now, it's a giant gray area that we just don't know. And these are the kinds of things that NASA is trying to test with its upcoming lunar landers. How much dust is getting kicked up? How long does it remain in orbit around the moon? How long does it take for it to clear up? Because we don't know what is the rate that we could send spacecraft to the surface of the moon for it to remain landable for future spacecraft. And that's still a big unknown. The gutless leading the clueless. Is it true that the first humans on Mars would have to bury themselves because the radiation would stay almost exclusively below the surface and in old volcanic tunnels? Yes. Yeah, I think it's safe to say that any humans that go to Mars are going to want to live underground. And that is because of the cosmic radiation and the solar radiation that is striking the surface of Mars. And it is going to deliver to you hundreds of times more radiation than what you experience on the surface of Earth. And radiation leads to cancer down the road. And so if you want to minimize the chances of getting cancer, you're going to want to spend the absolute bare minimum amount of time exposed to radiation from space. Now, if you've gone to Mars, let's say you've spent 9 months on Starship or some other spacecraft, and you've already been exposed and you've received essentially a lifetime's worth of radiation just in that trip to Mars, then when you get there, you know that you're going to have to, if you want to come home from Mars, you're going to have to spend another 9 months in transit. And so you don't want to spend that in-between time accumulating more radiation. And the good news is you don't need a lot of soil above you, like 1 meter will do the trick. So as long as you can pile up a meter of Martian regolith that's between you and space, then you're going to be fine. And you just have to remember, you have to be careful and time all of the moments when you're outside on the surface of Mars, as opposed to when you're protected from the radiation because you're underground. But yeah, there are some ideal places. I mean, there are these old lava tubes on the surface of Mars that are just already ready to go, places where you could set up a camp inside and then you're protected from the surface. And yet there's either if there's the skylight, but a lot of these lava tubes actually have exits. So instead of just you having to figure a way to rappel down from the top, they actually just exit out the side of a hillside. And so you just have to go in the side of the hill like a cave, and now you're protected from the radiation. So it is something that they're going to have to deal with and be aware of, but it's not a deal killer for exploring Mars. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers. Pam M, Ryan Q, Jim McCollum, Frederick Jensen, Mark Schachner, Pooh Cook, Sam Conaves, Tom Brown, Alistair McDonald, Ken Klatt, Arkham Fantasy, and John Tumbles. Join the club at patreon.com/universe today. Mr. Venison, are there missions in the works to visit the planet Uranus? Jokes aside, it's a very cool and weird planet that deserves much study. Currently, there are no specific missions that have been proposed and accepted in any state from NASA or China or Europe or anybody to go to Uranus. That said, in the last decadal survey, which was done in 2023, and this is where scientists from around the world come together and agree on what their priorities are. And for the planetary scientists, the priorities that they said were Mars sample return, some mission to go to Enceladus, and some kind of mission to go to Uranus. And so it is certainly, they wanted a flagship mission to go to Uranus. And there have been a lot of ideas proposed. I mean, you could have like a Cassini-style mission that would go into orbit around Uranus. And as you said, yeah, funny jokes aside, your anus. It is a really interesting world on its own. It's knocked over onto its side. What happened to cause this in the past? It has really interesting icy moons that orbit around it, each of which is a fascinating target. And we just have just a couple of pictures that came from Voyager 2. We don't have good insights into it. It has its own rings, and the rings are very different from the rings that we see at Saturn or Jupiter. And so it's a real tragedy. When you think about how many giant planets there are in the solar system, how many interesting places there are in the solar system. Jupiter has been heavily studied. Saturn has been pretty well studied thanks to Cassini. But we only got one flyby of Uranus and one flyby of Neptune. And yet these are giant, complicated worlds with rings and moons and an interaction with the outer solar system and the Kuiper belt. There's so much to discover. And so it was a priority for scientists. And so now it's just a question of when somebody's going to come up with a mission that meets that is relatively inexpensive, that can deliver a lot of science and fulfill those commitments. And we report on probably one new idea for a Uranus mission every 6 months or so on Universe Today. And we often talk about them on Space Bites here on this channel. And it's often people are trying to come up with a compromise, a clever idea. Well, let's use solar sails, laser sails. Let's do another flyby, right? And the ideas that I like the best are that you could actually do aerobraking through the atmosphere of Uranus. So you send a spacecraft screaming fast out to Uranus, and instead of giving it the ability to slow itself down with rockets, you have it dip into the atmosphere of Uranus and make a slight aerodynamic drag onto it, enough so that it now is in a very long elliptical orbit, and then it comes back around, passes through the atmosphere again, slows down a little more, keeps doing that, and then eventually it can circularize its orbit. And this has been done before. We know that this works with spacecraft who've gone to Mars. And so this idea would probably work on Uranus or Neptune. It's just, it's a little scary. So nope, there are no plans to go to Uranus right now, but hopefully there will be one soon, and we will get all of that additional science in the outer solar system. Mill. If a black hole is spinning near the speed of light and it feeds on a large mass, since it cannot exceed the speed of light, how do we reconcile the conservation of angular momentum? Right, so astronomers are able to measure the spin of black holes across the universe. And there's a few ways that they do this, and I've done interviews here on the channel about it, but the gist is either you can measure how quickly the sort of jets that are coming off of the black hole are turning, but you can also measure the accretion disk that's around the black hole. And so if you see a black hole with an accretion disk, and the accretion disk is very close to the black hole, then that means that the black hole and the accretion disk are spinning in the same direction. But if there's a larger gap, then in fact you've got the black hole spinning in the opposite direction against the accretion disk. And you can actually measure the rotation rate of the black hole. But black holes are limited at the speed that they can go. And in many cases, they're all right at the very top of that speed limit. They can't go faster than the speed of light. And in fact, they can't go, often they don't go, 99% of the speed of light. And that's because relativity kicks in. You know, you've heard that you can't go faster than the speed of light with your spacecraft because you need more and more fuel, and that the mass of your spacecraft increases as you go faster and faster and faster. And so you need more and more fuel to be able to go faster and faster. And so you're limited by just how much fuel you're able to carry. And you could never, like, the amount of fuel that would be required to move your spacecraft would approach infinity. And essentially the same process is going here. As the black hole is spinning faster and faster, you are getting relativity is kicking in. It's having a harder time to do its frame dragging, to be able to spin around. And the conservation of angular momentum, it's still baked in. It's still in that black hole. It's just because it is spinning it closer and closer to the speed of light, it is compensating for it. Enthusiastic techie. What's the most exciting discovery in astronomy in recent years? It's always really tricky to think of like what is the most exciting discovery, because there's sort of two parts to this. Like, one is there's stuff that I've been following for the 25 years that I've been a space journalist. It feels like I've been reporting on it for this entire time, and the progress has been very slow. I mean, there have been incremental discoveries that have been made, and yet you're sort of watching from a we don't know what this thing is to we probably know what this thing is to we're pretty sure, and now we know for sure what this thing is. And I've sort of watched this story happen several times. But I think the things that are most exciting are the ones that come out of left field that we never saw before. And so one of those, I would say, is gravitational wave astronomy, because before LIGO made its first detection of merging black holes, I think like 2015? So, not long ago, astronomers weren't even entirely sure that gravitational wave observatories were going to work. And yet they did it. They pulled it off. And you went from, we're not sure if this is going to work, to we actually have evidence of black holes merging out there in the universe. And now we're on the fourth run of LIGO. They've improved the technology over and over again. And now we get a detection a week of dramatically different sizes and scales and so on. And of course, we got the kilonova, where we got two neutron stars colliding with each other. And we also saw the electromagnetic flash of this kilonova event, which allowed you to confirm it, to say, okay, we've detected that these gravitational waves are happening, but we also observed the explosion from them happening. And we also got to prove that the speed of gravity is the speed of light all at the same time. So if I had to pick one that was the most exciting discovery, I would say it would be the advent of gravitational wave astronomy. Faisal Sahar, do you believe the efforts to search for life outside planet Earth have intensified over time? Yeah, absolutely. Like 30 years ago or so, you didn't look for life. Before that, back in the 60s and stuff, people had a lot of interesting ideas on how to search for life. On the one hand, there was the SETI program, the Search for Extraterrestrial Intelligence, where you had radio astronomers that were using telescopes to try and observe stars, to detect signals from advanced civilizations. And you had scientists that put together, say, the Viking experiment, where they had experiments on the Viking lander, which would scoop up some regolith from the surface of Mars, add some water, and see if you could detect the gases of happy bacteria living in the regolith. And they got some results, and people still argue whether or not the results are, yes, life, or just some kind of natural process. But in all of those situations, the search for life was seen as not legitimate, not important. And so we went through this kind of dark ages for a couple of decades, say the 70s and the 80s, where nobody could get funding to search for life. Definitely not to search for radio signals coming from extraterrestrial civilizations, but it was pretty hard to get funding to search for life on other worlds. And so you had to cloak it in other things. You're looking for the evidence of water on other worlds. You're looking for organic chemicals on other worlds. But in the 80s and really in the 90s, we got the rise of astrobiology as a field. And where this really came about was that people were starting to find that life, extremophiles, were able to survive in the kinds of conditions that are present across the solar system. So it used to be thought, well, no, Earth is the only place you're going to find life. You need water, you need warm temperatures. That's what it's going to take. You need reasonable acidic conditions. But in fact, scientists here on Earth have been finding life in the saltiest places, in the coldest places, in the hottest places. Really, wherever you have liquid water on Earth, you seem to find life. And so now those places start to match to places across the solar system, places like Mars, where it's really cold, maybe places in the upper atmosphere, in Venus, where the temperature are reasonable, and maybe there's some way that water can exist, or under the ice on places like Europa and Enceladus and places like that. And so once scientists realized that life was a lot more durable than they had previously believed, it opened up this field to start looking for life on other worlds. And you got this field called astrobiology. But still, searching for intelligent aliens was considered something that wasn't legitimate. And really, it's only been in about the last 5 years that government funding has now been flowing to projects that want to look for some technosignatures, some evidence that there are intelligent civilizations out there. And now there's a lot of really interesting partnerships that are showing up. You've got radio astronomers that are giving their data over to the SETI Institute so people can study them to search for signals for aliens. You've got NASA hosting forums where astrobiologists and people who are searching for technosignatures can come together and talk about their ideas. And I think they've done multiple of these conferences now. And so, we see a lot of papers published into journals where people with a straight face are saying, I'm looking for Dyson spheres, right? Which before would have just been ridiculous. So I'm sure there's a lot of people out there that still kind of think it's ridiculous. But now when you think about, say, the Habitable Worlds Observatory, which is the next telescope that's going to come after James Webb, after Nancy Grace Roman, is a telescope specifically designed to scan the atmospheres of Earth-sized worlds orbiting around sun-like stars to search for biosignatures, evidence that there's life there. So yeah, I mean, everybody's always known that that's what you want to find. We really want to know if there's life out there in the universe. And it's only been in the last couple of years that the funding has matched both the public and scientific demand to get answers. Giovanni Foulmouth. Do all neutron star collisions create black holes? We don't know. So the neutron star collision, the kilonova, was first seen back in 2017. This was where we got that gravitational wave observatory observation, as well as the electromagnetic observation of two neutron stars colliding. And in the resultant explosion, we saw many times the mass of Earth in the form of gold and other heavier elements that had come together. And it looks like this is the answer for short period gamma ray bursts. And these were a mystery for a long time. What is the cause of short period gamma ray bursts, as opposed to the long period gamma ray bursts, which appear to be core collapse supernova? Anyway, but then the question is, what's left over? So there are a couple of possibilities. So one possibility is that when the two neutron stars collide with each other, they just detonate. And there's nothing left over, just this expanding cloud of debris left over, of gold and platinum and all these stuff that came from that collision. And it's likely now that a lot of the heavier elements that we have here on Earth, the gold in your wedding ring, that came from kilonova and not from supernova as originally thought. The other possibility is that you get a black hole where you've got, two objects that are compact, that both of which are really almost black holes. They're between 1 and 2 times the mass of the sun. A black hole starts around, more than 2 times the mass of the sun. So if you mash two of those together, maybe you get a black hole. And then the other possibility is that you get a neutron star, because it's not massive enough for a black hole, but you get a long-lived neutron star as a remnant. And the jury right now is still out. So there's a lot of really interesting discoveries that have been made where astronomers are seeing the maximum possible mass neutron star, which is a very weird thing to see. Like, how do you get a neutron star with that much mass? Is it feeding off of some companion, or did it entirely feed off of a companion and now that companion is gone? You're seeing the minimum mass possible black hole. That's weird. Did that come from a neutron star that just tipped over and became a black hole? So no remnant has been detected from the 2017 gamma ray burst that I know of. But astronomers are definitely searching for one. If they find one, or in any of the other kilonova events that have happened since then, we'll get a sense of what the remnant is. But right now, all three options are possible. Sorak 311. We know the fastest speed of the universe, but what is the slowest speed? What is still? What would the time dilation be for something at complete still? So that's a trick question, because everything is relative. And so there is no such thing as completely still. You always have to ask yourself, compared to what? When you think about you versus your chair, from your chair's perspective, you are completely still. But from a car that is driving past your house at 60 kilometers per hour, you are moving at 60 kilometers per hour compared to the car. And that same thing goes for everything, that you appear to be sitting on the surface of the Earth and you're not moving, but the Earth is turning at 1,000 kilometers per hour. The Earth is going around the sun at 30 kilometers per second. The sun is going around the Milky Way at 250 kilometers per second. The Milky Way is drifting through the universe at, 500 kilometers per second compared to the cosmic microwave background radiation. And so there is no place that is still. All you can ask yourself is compared to what? And then if you want to measure the time dilation, you have to measure compared to the observer. And so there is no such thing as still. Stopped. There's no such thing as being stopped. Wayne Elkins, given a super duper telescope and suspend the speed of light limit, what are the chances we could look out and see the back of our head? So the question you're really asking is the universe infinite or is it finite? So if the universe is infinite and you have a super duper telescope and you have suspended the speed of light, which means that you can now look in all directions forever. If the universe is infinite, you're not going to see the back of your head. But if the universe is finite, in other words, it is a specific size, in the same way that the circumference of the Earth is a specific size, then if you travel in one direction on Earth, you will eventually come back to the back, tap yourself on the back of the shoulder. And so same thing, if you could point a super duper telescope and not worry about the speed of light, and you point it in any direction, you would see the back of your head. You'd be seeing the other direction. You look to the left and you'd be seeing the right side of your body. Look to the right, you'd be seeing the left side of your body. Look up, you'd be seeing your feet, and so on. And then how big is that finite universe? Is it 50 billion light years across? Is it 100 billion light years across? Is it 1,000 billion light years across? Is it a quadrillion light years across? We don't know. We don't know the answer right now. We know it's at least several hundred times bigger than the observable universe that we can see, but we don't know the minimum size. We don't know how big the actual universe is, and it's also easily, possibly, probably infinite. Jesse M. Does anyone think that our loudness in space will attract a dangerous civilization? So this is like a trope in science fiction where the aliens are watching Earth and they're detecting the transmissions from, say, the 1940s, World War II, things like that, and this is absolutely happening. Like there are these expanding spheres of radio transmissions coming from Earth, and they are matched to your distance away from planet Earth. And so if you are 10 light years away, you are seeing the radio transmissions coming from Earth as they looked 10 years ago. And we've been transmitting radio waves into space for about 100 years. And so there is a sphere around the Earth of about 100 light years that anyone in that area with powerful enough radio telescopes could detect the presence of Earth by our transmissions. And that's actually a lot of stars. Like, it's probably in the 50,000 to 100,000 star range. So there's a lot of targets out there that could be looking at us. But the reality is that even though the transmissions might be very powerful, they attenuate over time, and you need an incredibly powerful telescope to be able to observe us here on Earth. That said, we're in the process of building a radio telescope that is powerful enough to detect the presence of Earth from a distance of 100 light years away. And that is the Square Kilometre Array, which is being built in Australia and in South Africa. And once completed, if you targeted planet Earth, you would be able to detect, say, some radio transmissions coming from our planet, like especially things like the radio air traffic control systems, which are very powerful radio. You would detect the presence of those. So if there are alien civilizations and they are more advanced than us, then, depending on how far away they are, they will have detected some level of our communications. Do I think it will attract a dangerous civilization? No, I don't think so. Because, yes, we've been transmitting our radio waves for, say, 100 years, but we have been filling our atmosphere with various kinds of pollutants for a lot longer than that. Think about when the industrial age started up. Some alien civilization that is 300 light years away could be observing the atmosphere of the Earth and detect the presence of sulfur dioxide, coal, smoke, things like that, and detect the presence of humanity. They could detect the presence of chlorofluorocarbons more recently than that. And then if you go even earlier than that, you could detect, say, the presence of wildfires burning on Earth, contributing smoke into the atmosphere. And really, all the way to about 500 million years ago, when we got the Great Oxidation Event, when just cyanobacteria filled the atmosphere of the Earth with oxygen, that was the moment that some civilization far away could detect Earth and go, there is a biosignature on that planet. Let's go take a look. And they would send their von Neumann probe to come and scout us out. So, if we were going to attract a dangerous civilization, we would have done it already. All right, those are all the questions that we had this week. Thank you, everyone who asked questions in the YouTube comments, and thank you to everybody who joined me for the live show. Now, we do the show every Monday at 5 p.m. Pacific time. That's the live show, and it is twice the length, an hour that gets edited down that you're seeing, as well as an additional hour that we call overtime. So you should come and definitely check out the live show. It's great. We have a good time. Lots of people ask great questions, talk to each other. So come join us 5 p.m. Pacific time. Now, I'm going to talk about a book that I'm reading as well as a TV show that I'm watching. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew Gross, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modso, Paul Rohrbach, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So first, I've got a book that I want to talk about. So 2 weeks ago, I mentioned that I finished reading Demon by Daniel Suarez, and this is the first part of a 2-part series. And so a bunch of people in the YouTube comments said, oh, you should read the second part. It's really good. So I read Freedom, which is the second part of the book. And I agree. Freedom was really good. It didn't go in the direction that I was expecting. I was sort of anticipating a horrible outcome for humanity by a rogue AI, but in fact, things took a weird turn, and I wasn't expecting it, and yet I was delighted, and I enjoyed how the rest of it progressed. Although, the book is about more than 10 years old, and so a lot of the ideas in it have been sort of well worn, and I think we now have a much more nuanced idea of what is an existential risk. And so sort of hearing people grapple with these ideas, 10 years ago, compared to thinking about the kinds of existential risk that people are thinking about today, so it just shows you how much new existential risk we're facing. But anyway, so you got Demon and you've got Freedom by Daniel Suarez. Definitely, I enjoyed both of those books. Now, the TV show that I want to recommend to you is going to seem totally out of left field, but this is Delicious in Dungeon, which is an anime that's appearing on Netflix. And I am just delighted by this show. It is about a group of adventurers who are attempting to delve into a dungeon, and they're limited by how much they're able to eat. They get hungry and they have to go back to town to resupply, and they meet a dwarf who is specialized in cooking in the dungeon, and they realize that all these monsters that they're trying to kill are actually food, and they just have to learn to adapt their palates. And it is the most wholesome show I've watched, and I'm really enjoying it. So if you're looking for something kind of fun to watch, Delicious in Dungeon on Netflix. All right, we'll see you next week.